This is kind of the worst case situation. We have two different fractions on both sides and we don't have 0. Well, that means I need to take the one fraction on one of the sides and move it over. So how do I do that? Well, it's a positive 2 over x plus 3, so I'm just going to take the whole thing and subtract it. So if I do that, though, I still have my 4 over x plus 1, and moving the 2 over x plus 3 gives us a minus 2 over x plus 3. But at the very least, it makes the other side 0. The problem is I need one fraction on the left. So to make these turn into one big fraction on the left, I need a common denominator. Well, my common denominator needs to actually have both denominators because they're completely different. So my common denominator is going to be an x plus 1 and an x plus 3. Well, the first fraction already has the x plus 1. It's missing the x plus 3. So I've only got to multiply the top and the bottom by an x plus 3. The second fraction has the x plus 3. It's missing the x plus 1. So that one needs to get multiplied by an x plus 1 on the top and the bottom. And again, we're doing this so we get a common denominator, which now they have. It's a common denominator of x plus 1 and x plus 3 on both fractions. That means now I can put them together. Well, on the first fraction, I have a 4 times x plus 3, which will give me 4x plus 12. And be careful, on the other fraction, I have a negative 2 and an x plus 1. So I'm distributing a negative 2 to the x plus 1, which gives me a negative 2x minus 2. Still need to combine like terms. So let's see what happens. I've got a 4x and a negative 2x, which is 2x. And what else do I have going on here? I have a 12 and a negative 2, which would be 10. So, and I still have my common denominator of x plus 1 over x plus 3. Now notice, this was just part A, and we equal 0. Part B would still be less than 0. And part C would still be same idea, but now greater than 0. So I'd still have to do the same thing we did in the previous problems, which is start out with 1. When does the top equal 0? Well, the top equals 0 when 2x plus 10 equals 0. So you'd subtract 10 from both sides, which would give me negative 10. Divide both sides by 2, which would give me negative 5. So this would be the point when we cross the x-axis here at negative 5. Continuing right along, we'd also care about when does the denominator equal 0? When does the bottom equal 0? Well, the bottom, thankfully enough, equals 0 whenever x plus 1 plus times x plus 3 equals 0. That was our denominator. Well, that's going to happen when either x equals negative 1 or negative 3. And again, these are special when the denominator equals 0. These are vertical asymptotes. Okay, so let's put this all together to help start off our graph a little bit. So we've got 3 values this time. We've got negative 5, where I'm crossing the x-axis at a point. We've got negative 3 and negative 1. Well, negative 3 and negative 1, those were my vertical asymptotes, so I'm going to draw my little dotted vertical lines. Now I just need to break this up into, it's not 3 pieces this time, it naturally breaks it up into 4. What's happening before negative 5? What's happening between negative 5 and negative 3? what's happening between -3 and -1, and what's happening lastly after -1. So that's 4 regions this time. So let's test our 4 values. And again, we're going to test them into our redone equation with the 0 on one side, which is 2x plus 10 over x plus 1 times x plus 3. So the first thing you'd want to do is test something from the first region, which means something smaller than -5. Test, let's say, -6. Plug it into your equation, the 2x plus 10 over x plus 1 times x plus 3. And again, you're just looking to see if you get a positive out or a negative out. Well, if you plug in a -6, you get a negative on top and you get 2 negatives on the bottom. Well, the 3 negatives will still end up giving you a negative answer, which means that first region will be below the x-axis, be negative. Now let's test something in the second region, which is between -5 and -3, which best number would be -4. Well, with -4, we get a positive on top, but 2 negatives on the bottom. Well, the 2 negatives on the bottom will cancel out and give you another positive. So we'll end up with a positive on the top and a positive on the bottom, which will give me a positive, which means I'll be above the x-axis in that region 2. Okay. Now, region 3 is wondering what's going to happen between -3 and -1. Well, let's plug in a value. Best value is -2. Well, that gives me a positive on the top and a negative for my first set on the bottom, and then a positive for my second set on the bottom. So because there's only one negative, my answer will be negative. That means the entire area on region 3 should be negative and getting closer to both asymptotes. So it should be looking something like this. So that loops down and stays down because I don't cross the x-axis anywhere in the middle. I only found out I crossed the x-axis one place at -5. That means I don't cross it anywhere in between. Okay, last value I need to test is something that's going to be in that fourth region, something a little bit bigger than -1. Perfect value to test would be something like 0. So let's see what happens when you plug in 0. Well, if you plug in 0, let's see, you get a positive on top, a positive on the bottom, and another positive on the bottom. So, well, all positives means my answer is going to be positive. So it means in region 4, the entire thing should be positive above the x-axis. So let's see. Now I should be able to answer all 3 questions because I've got my entire graph of all